In this video, we're going to talk about the quotient rule. And what does quotient rule mean? Well, we learned about the power rule, not the power rule, the product rule, which is when things are being multiplied together. And what about division? Well, division, another word to say you're doing a fraction is to say you're doing a quotient. So this quotient rule is going to be the rule for when we're doing division with functions. And the rule looks like this. So you can see we have division between f and g, and the rule on the right. All right, so if we just look, we keep the original g and the derivative of f get paired together, minus the original f times the derivative of g, all over the original g squared. All right, so there's one thing that's important for this one. If you look at the top, it's really similar to the product rule. We have a function paired with the derivative, and we have both of those pairs together. The only difference in the product rule, there was a plus sign in the middle there, and it didn't matter which order I did it in. But with the quotient rule, it does matter, because if you mix them, you flip them, then a minus sign, you can't just flip things. Your answer will be wrong by a minus sign. So it's really important you get the order correct when you're doing the quotient rule. It's not as important for the product rule because of that plus sign. All right, so how can you make sure you get them in order? Well, one, you could just remember the first thing you do is put the bottom on the top and kind of go from there. That's some ways I kind of think about it that way when I'm doing a lot of quotient rule problems. But if you're not doing a lot of quotient rule problems, you kind of just have to have a quick way to remember. This is the way. This is the way. There we go. This is the way that I learned it when I was in high school. All right, so if you have the high function because it's on the top, and the low function because it's on the bottom, then you take this quotient rule by doing low. So low means the original bottom function. D high, D means derivative, minus high, original top. D low means derivative over low low, and low low because there's two copies of that one. So low D high minus high D low over low low. It's kind of fun to say. All right, so if you kind of remember that phrase, you can remember the order as well. But the most important thing is the first thing that you write in the quotient rule is that original bottom function. All right, so here we want to take this derivative. In the product rule, there was kind of shortcut, well, not shortcut, like a different way you could do it. You could just FOIL everything out and then take your derivative. For the quotient rule, there's really not any way. You kind of have to do the quotient rule if you see this division bar. All right, so how do I find f prime of x? And order is important. The first thing I do is low, the original bottom function. I multiply that by d high, the derivative of the top function, the derivative of 5x squared. I multiply, get 10x. And then I subtract. So I just did low d high, next is high d low. So I do the original top function, I guess just the opposite of what I just did, times the derivative of the bottom function, and that's 4. All over the original bottom function, which is 4x plus 3, all squared. One thing is, don't think you can cancel out the 4x plus 3's because you see one on top and bottom, because there's all this extra multiplication and subtraction and stuff going on. You can't cancel those out. So this is the final answer. Again, for time in the video, I'll leave it here, but you could kind of combine like terms and stuff on the top to make it look a little bit simpler if you actually had to plug in values and stuff like that. If you saw it on a multiple choice test, it'd be in the simplified version. But for now, we'll just leave it like here, just making sure we know the quotient rule. Now we're doing the video about the quotient rule, so we're going to use the quotient rule in all these problems. Again, we're just making sure that we get the pattern correctly and plugging everything in correctly. So the derivative of this is low d high minus high d low all over low low, which is the original bottom squared. So I know I did it quickly, so let's go through it. So the original bottom goes first. The derivative of the top goes second, so x cubed turns into 3x squared. 2x just turns into the constant 2. And then I switch it. Now high, the original top function, d low, derivative of 3x squared is 6x. And then the original, this is kind of one of the most common mistakes, is people put the derivative of the bottom on this part, but it's the original bottom function and then squared. So that's the quotient rule, just following that pattern. Again, remembering this is the most important part, that you get the first part right, because then you won't be wrong by a minus sign. All right, so here's the one for you to try on your own. Go ahead and find the derivative of this function using the quotient rule. I'll show you the answer in 3, 2, 1. All right, here's the answer I came up with. Again, original top function goes there and there. And you just follow the pattern, the other derivative, the other original, the bottom derivative. All right, if you're just following that pattern, you can do the quotient rule. All right, so here's the important stuff again. The quotient rule has a negative in it, or subtraction sign. So you got to remember the order correctly. All right, and also in the denominator, it's the original denominator squared. All right, so now we have this product rule and quotient rule, and really the whole thing now is A, getting them memorized, all right, making sure you know what the rules are, and B, making sure you actually use them when you run into them. So if you're doing a bunch of derivatives like x squared, you know that's 2x, x cubed, you know that's 3x squared, and then you see like x plus 2 times x squared minus 1. And then you kind of forget that you have to do this more complicated rule because there's the multiplication there. So just make sure whenever you're taking the derivative, you're on the lookout for, is there a multiplication between big things? Is there division between big things? And you got to do these extra rules to get the derivative correct.